Action!
Good afternoon everyone and welcome back to my channel. Thank you for tuning into this video. As you might notice, I've got a new condenser mic here. I got that term wrong when I was practicing. I'm not going to say which word I used, but yeah, so I got this new mic for my birthday about a month ago. It's roughly a month ago. And just wanted to test it out in a new video on my channel, see what it's like and how it's going. Basically this video is going to be about what kind of work I do, what I do in the field, what's all the terminologies and what the ins and outs into it. So yeah, let's see how this video goes. I'm testing a few things in this one.
So there's a lot of metrology actually being tested in this video itself.
That is the kind of work that I'm doing at the moment, is that I'm classified as a metrologist. I go to places where they basically measure things. So metrologist is considered to do different engineering and science things. They need to know measurements of like different things. So what I'm working on is mass, so basically like weights. Also another field that I work in is electrical, so I work with electricity, volts, amps, resistance, all those goodies. And then once I've like kind of mastered or got it under the belt of how to do the different fields, then I go on site and I measure the different whatever there is ranges. So let's say like I'm measuring a balance, then I would put let's say 10 kg. So let's say the average human weighs between, let's say, 40 and 120, or in between there. Then I use my mass pieces, which is about 20 kgs each, which is the heaviest I can go, or it goes all the way down to 1 milligram, which is very, very small. If you lose that thing, you're going to be looking for days, or you're going to get into big trouble. Either one. So yes, basically I got my standard, and then I got obviously the UUT, which is the unit under testing. So basically I use my standard, which gets calibrated from higher people. In South Africa we use SANAS, which stands for, I think, South African National Association Standard, something like that. If not, I'll correct myself on the screen there. And then obviously they get accredited by international standards. SANAS is the national standards for South Africa, which we get calibrated from, so we right under them. And then from SANAS they go up to international, which is probably the France standards. I can't remember the term right now. I'll also hold it onto the screen just so you guys can see. The national standards, Peru, something like that. You guys might have heard of the term before, but I was just trying to familiarize myself with a few videos that are on YouTube. And basically metrology can be used anywhere in life, anywhere and everywhere. So from a project, from let's say your cell phone or your computer that you're watching this video on currently, to a massive building, a skyscraper outside, or let's even say this camera right here that can also use metrology. It's basically just to check the accuracy of different things. Our labs can accommodate like temperature, we can do humidity as well with temperature. Then we go to the lab next door, which is pressure and pneumatics and all those, gravity. And then next to that is the mass lab, where you get your weights and not pressure, balances and scales and small mass pieces. I'll put pictures on just so you guys can see and relate to what I'm talking about. And then we move upstairs where we got the radiofrequency labs, which is like what your cell phone uses to communicate to the cell phone towers, your internet, like your Wi-Fi, things like that. And then there's also the dimensions that we're also going to bring in soon, like for example a ruler with centimeters or inches, or basically measurement. And then I wouldn't say the biggest lab and the most fun lab for me is the electrical lab, where we basically test anything from a small multimeter, which looks like this, to massive power supplies and even bigger things where we can't take it from off-site. So that's why we go on site and test them. We put in, like, let's say 100 volts, for example, like zzz, goes in this side, goes through the whole power supply or the system that we're testing, which is considered the UUT, unit under testing. And then outside this we put our multimeter, which is our standard. So we've obviously got measurements for this multimeter on this side and whatever is on this side. So then yeah, once it goes through the whole system, we can measure what this gives us. Now, what is a cal cycle, you might ask? Well, a cal cycle, a calibration cycle, is basically how long you think that unit can be trusted for to hold those values. That's the way I understand it, at least. So basically, let's say we put in now the 100 volts into this power supply, and within 2 months then it fluctuates, let's say 5 readings, so digits, so then it goes to 105 volts in, what did I say, 2 months or so. And then a year later then it's already like 20 or 30 units out, and that's just way too big. So that's why the history of a unit is so important, so that we can determine where the gradual line, the linearity or whatever of that unit is going towards, so that we can have an idea of plan how long the cal cycle can be. So normally we put a calibration cycle of 1 year, so 12 months. Then we know every year the unit drifts is the term that we use, from 100 volts to 105 in 2 months and 110 in 4 months. But if a unit drifts by that much, it's really not a reliable unit, just to put it out there. Generally in the electrical department, the best unit to go for, like the best is Nike or Adidas or anything like that, you'd go for Fluke, which is the picture that I'm showing you, mainly because it might look familiar to you or you might have seen it before. So yeah, that's basically an electrical mass. Basically what I do is I take these mass pieces, I'm going to try and edit it so it follows my hand, then I put it on the balance. So let's say the microphone is the balance, I put it on there, I get my reading, whatever decimal points there is. So let's say there's 4 or 5 decimal points, I take it off, then I go through the whole range. So let's use the human scale for example. Let's say it goes up to 200 kilograms, then I start by 0, like right at the bottom, then I go to 10, 20, 30, okay, maybe not that little bit increments, but normally I take like 5 readings. So I'd go 5, no, not 5, I'd go 20, then I'd go 60, then I'd go 120, 180, and then 200 full capacity. So I get the readings of the full range of that balance, and then I obviously know where it's, like let's say where I measured it at 20 kilograms, it's out by this little bit, and then when I measure it at 200, it's out by this much. And that's why it's important to calibrate the whole range, so that we know where it's, the uncertainty is the biggest, or the units are out. And then how to calibrate it. Now here's a big thing, how we actually make the real deal, and my work consists of is basically it's easier to do it on a balance, because you normally have a cal button that you press and it goes cal, and then it tells you to put a certain amount on. I put my 1 kilogram or whatever it asks me to, I put on the balance, and then that balance takes that 1 kilogram or 200 kilograms, how much ever I put onto that balance, as the new standard. So I'm using my standards now to measure against the UUT, so the balance now is the UUT. So now that balance, which is the UUT, takes that, let's use a 1 kilogram just for argument's sake, then now that balance sees my 1 kilogram as the new kilogram. So then it can make adjustments throughout the whole range, up to 200 kilograms even, and say that from that 1 kilogram that I put on the balance, now it can make adjustments and corrections along the whole way. And yeah, that's just basically to explain how I do my work. I don't know if I've overlaid the footage already of me driving through. I'll see in the editing stages of this video, because I can imagine that this is going to be a very interactive video. I can imagine, I don't know. I don't even know how my voice sounds like. Does my voice sound sexy? Or is it very, I don't know, is it very soft? Because I maxed out my recording volume here so that you guys can actually hear me. I've tested it out before, like I do everything. I'm a metrologist, I'm a technician glorified. And yeah, so where was I actually going with this? The footage. I was doing some footage yesterday. I'm not actually allowed to, but I don't show at all where I am, like the company's things, so if there's any confidentiality things in there, then I'll obviously blur it or cover it up. So yeah, just to show you that it was a sugar plant that I went to, where they take corn and they turn it into corn syrup or sugar or sweeteners, whatever, I don't know. But the end product is very cool, and the waste product, or I don't know what the term is, but like the excess stuff that they take out from the corn, let's not go there. It's very disgusting and smells. Luckily I was wearing my mask. I'll show you guys a picture, standing in front of a sign with a danger zone. They used to use trains. I made a joke on my WhatsApp status saying that they actually mean snakes, but yeah, no, that's not actually what they mean. They actually mean the train tracks are live, and if you step on them, you literally die within 2-3 seconds. So yeah. Oh yeah, this morning I was trying to do the certs for the work that I did yesterday. Certs is a certificate, so I issue then a certificate to the work that I do of the calibration. Just see this lighting doesn't go off Hong Kong. So yeah, basically I measure, like I said, I go through the whole range of the balance from 0 kilograms all the way to 200. Then I issue it on a certificate. Now this certificate is the most important part of the calibration. Well, actually there's two important parts to the calibration. When I do the calibration of the balance or the scale, I put a small sticker key on it just to show that it has been calibrated, so that if you're trying to reference the calibration to a certificate, you at least have a number. You got the serial number of the UUT, which is the balance, and a certificate date cycle. So let's say today's date is the 6th of March, then if it's a 12-month calibration cycle, then it will be next year, 6th March, which will be 2022. So yeah, just to let you guys know, that's the sticker, which is part 1. Part 2 of the important part of the calibration is the certificate, where you put all the details of the client, where the UUT is located, the conditions. Environmental conditions is also a very important thing, like the temperature, the humidity. In the pressure lab you also need the bars, the pressure, you know, I don't know, you know what I mean. I'll put it here on the screen. So yeah, all those things are an contributing factor to the calibration. It can influence my readings, and yeah, just so we jot that down all on the certificate, and then I'll go to page 2. I use my references. So if I use let's say my 1 kilogram on the balance now, I need to state which mass piece set I use. So I've got a set of 28 mass pieces. Like I said, you get all the way from 1 milligram all the way to 20 kilograms. So like from this small literally up to this big. The block is like a brick, and it's a cube almost with a rectangle, and you carry it like a brick, and it's 20 kgs. Now imagine doing a 600 kg balance. Like you're gonna need 1, 2, 3, 4, basically 15 of those, which is gonna, no, that's 300. 600 is how much? 30 of those, and it's quite a good workout some days. Like, it's a gymming workout in itself. Anyway, so then on the certificate, then I jot down the results that I get. So if I get 1 kilogram, okay, and sorry, here's another important factor of the calibration in a balance. So like I mentioned earlier in the beginning of this video, you get the resolution of the balance. So normally your balance at home will probably give you 1 resolution or 1 digit resolution if it is an electronic balance. So what that means is, let's say you weigh 50.1 kilograms, for example, then that 0.1 is the resolution that it measures in. Okay, cool. Now that we've got that established, so the resolution is also a very big contributing factor. Like in some of the laboratories that I go work in, I think the most accurate balance that I've done is up to 6 decimal points. So like I just explained, your balance goes up to 50.1. These balances goes up to, it's maybe a 100 gram balance, so it's like 100 grams is that big, and then decimal points of up to 5. So you get 100 grams, 1, 2, 3, 4, 5, 6 digits, which is flippin' accurate, and it takes a while to stabilize. Because it's so minute, and you know, like temperature, heat rise, hot air rises, cold air sinks again. Getting a bit lost in my own words. So you imagine that if if a mass piece gets hot, then it'll obviously be a bit lighter, and if it's colder than it should be, like the environmental conditions that I spoke about, it's also going to sink a bit more. And that's why those accurate balances are so crucial to keep the environment conditions between a certain point. So let's say you got a range between 20 degrees Celsius and 25 degrees Celsius. Now that's very narrow, but some labs do require that because they work with medication or cell phones or things like that needs very accurate precision, because let's say they put in 100 milligrams too much of sulfuric acid or chlorine or something in a pill, and you consume that, you could possibly die or have serious injury or illnesses coming along with that. And that basically, ladies and gentlemen, is why metrology is very important, and that's why I love my job. Because there's a lot of room for improvement. There is also a lot that I still got to learn. I've only covered 2 fields, not even covered all of it. I've still got a lot to learn in those fields, but I'm only working in 2 fields at the moment, which is mass and electrical at the moment. There's still, like I mentioned earlier, pressure, there's electric, keep getting stuck on electrical. There's still temperature, radio frequencies, and lots of more. I think we've got one more lab to cover, then our company can basically cover all the metrology. And I don't think we're the biggest in our country, which is South Africa, but we are almost one of the highest for accreditations, which means that we can do a lot of work, and also that we can do a lot more things, higher precision works, things that we've been accredited for through SANAS, which other companies don't have yet, because it takes time, it's expensive, and you need a lot of time and people that can do your work while you go on courses and train for those things. And the training is very, very stressful. Like, I've only been on 1 course so far with a mass, and yeah, let's say I was stressing, and I also just passed that test, so I'm very grateful for that. So yeah, I don't want to make this video for too long, but if you guys do enjoy this kind of vlog videos, or maybe you like my mic, or I don't know, the reason why I don't want to show you guys my room is because it's still in a bit of a mess, and I'm going to have a bri this afternoon, so I still need to clean up and edit this video quick, and then we'll see where this goes. But wait, before you jump off this video, please smash that subscribe button and hit the like button, please. I really do appreciate it. Put your thoughts in my comment section down below. Let me know what you guys think. If you also know another metrologist, if you got any thoughts that you can share with me, let us discuss it down there in the comment section. And yeah, last of all, stay awesome.